Welcome to another session, Data with Nikk the Greek. And today we're gonna follow our journey of partitioning, especially when loading Parquet files. That's where we're looking right now. We understood the algorithm, how it's working, what the partitions are influenced by, and we also looked on one of the parameters in the last episode, MaxCostsInBytes. Today we're gonna take a look into a second parameter, which is OpenCostsInBytes, which is a little bit trickier to understand, but we really gonna get all which is important about this parameter to go out with the know-how at the end of the session. So first of all, what's the max cost per bytes? Um, so basically, as you can understand it, it's as the name already says, it represents some kind of cost, and basically the cost of creating a new partition. So you can set this config by Spark SQL files OpenCostsBytes using spark.conf, and it defaults to 4 megabyte. And so what does it actually cost? Where is the cost coming from? So basically, especially this value gonna be active when you have really small files. So imagine you have a lot of kilobyte files. And normally what's happening is if you have a partition which allows up to 100 megabytes, for instance, all those small files would get into the partition. But you also learned that scheduling a lot of small files, which is also similar to scheduling a lot of small partitions, is a lot of overhead. And this cost relates to the overhead of Spark of loading, or the cost of Spark to load one single file of data. And that means if you have bigger files, so you just load 1, 2 files, but there's a lot of scanning happening in the background, etc. Some interaction with Spark is doing, and basically by virtually giving some additional size to this very small file. So Spark thinks the file is not kilobytes big, but it's roughly 4 megabytes big, and by that less files go into one partition. And that's basically what's meant by open cost per bytes. And the influence usually happens in smaller files. In bigger files, you will not see it. So with smaller files, I mean a lot of small snappy Parquet files in the background for Park, for instance. And that's where we're gonna have a look today with a smaller data set. So how does our data set look like? It's pretty much the same number of rows of our data set we used for MaxCostsInBytes, just that, okay, why is this not going away? So just that we have 4,500 files, which are in average half a megabyte. I probably could have done it even smaller, but I went for a half megabyte now. So, and what we're also doing is we do the same experiment as for MaxCostsInBytes. We just go through different configurations. So from 2010, 5 megabyte up to 0 megabyte for the open costs. So, and let's have a look into the results. So first of all, let's have a look here on our default value. And what you can see is we have a size per core padded, which is quite big. And so you remember our size, total size was 2 gigabytes. And we would have like roughly 500 megabytes per core if you divide the 2 gigabytes per core. And if I remember myself correctly, with a bigger data set, we have there roughly around 570, if I remember correctly. So this is like a significant change. And this significant change comes really from this virtually added, meaning padded 4 megabytes to each small data set. So roughly, if you have here 4,000, how much did we say? 4,000 files times 4 megabytes. It's basically this big part which has been added additionally. So, and you see now, okay, actual number of partitions is 156. But what you can see is, and there you can see what cost actually means. What it's doing is, when you reduce the value, so even up to 0, you're gonna realize, okay, now it really reduces the number of partitions. That means each partition has significantly more files into it. So with 4,000, let's make the test. So we have 4,000 files divided by 17. It would roughly mean that, okay, 265 files per partition is in there, and that's this sounds already for me like a really big overhead. And if you're gonna go with 4 megabytes, you're gonna have significantly more files in there. So roughly 29, which sounds way better. You can also see in the performance that the performance also has some influence on it. So you can see with 4 megabytes, we need 27.94. Here we have a little bit more. Actually surprises me that in my case, it even had such a big difference. Usually if you have a look on this experiment, it doesn't have the biggest influence. But it also depends on the I/O, and my SSD might not be the fastest one in this case, but still support that it can have some influence. And the biggest influence you're gonna see is really when you have really big data sizes, 10, 20, 50 gigabytes, or even terabytes big, where you have like really small data sets. Of course, OpenCost is only one piece of the puzzle. There are also other options, but we're gonna look into the next sessions how you more efficiently can load and process the data doing narrow transformations. But this can make a difference. And if we increase a little bit, I was also curious by myself what happens if you increase the value. It can also go the other way around, and you make the process slower. So basically in this case, we have 643 partitions, and this means that, well, probably around 7 files. Yeah, okay, good guess. 7 files have been loaded into one partition. And it seems like the cost has been estimated here just too big, that the overhead of having too many partitions now became bigger than the overhead of loading too many files into one partition. And yeah, apparently the 4 megabytes, probably the guys did some evaluation to set a good default value. It's actually not too bad set. So now probably with the next execution, the execution time might vary even. But it also shows that usually you don't really need to adjust this parameter significantly. Only if you have like bigger data sets with a lot of small files, you'll really see that this might influence, or a lot of small files end up into one core. You might even increase it a little bit more. It would be worth to try the same experiment instead of 0.5 megabytes to have like a kilobyte files for 2 gigabytes. I could imagine this case that increasing this value might have a bigger influence. And that's already it for the open costs. Looking forward to show you in one of the next episodes what other options, not only adjusting the partitions, we have to make the loading and processing of data doing narrow transformations more efficient. But until then, thanks a lot for your time. As always, feel free to subscribe to the channel if you like this video, and we see each other soon in one of the next episodes. Goodbye.